let's examine the following compounds. We have HF, H2, H2O, and CO2. Let's start with this HF molecule here. HF is composed of hydrogen atom and fluorine atom. Here, hydrogen is non-metal. And the same thing for fluorine. Here it's also a non-metal element, so it's non-metal plus non-metal. This one is a covalent compound. On a covalent compound, the atoms are sharing electrons. So H, it has 1 valence electron. F, it has 7 valence electrons. So they share these electrons over here. We can simplify this by writing as this one. So we can remove the extra electrons that is not shared to other atoms. Here, hydrogen and fluorine are sharing this set of electrons over here. So H is using this, and fluorine is also using these 2 electrons over here. So let's discuss the concept of electronegativity. Electronegativity is the power of an atom to attract electrons to itself. It refers to the strength of the pull of an atom to attract electrons to itself. So these are the different values. So it's also present in your table of elements. So here we have H. The electronegativity for H is 2.1, and the electronegativity for fluorine, that's 4.0. So here we have different strength, obviously. So fluorine is obviously much more electronegative compared to hydrogen. So here fluorine is pulling these 2 electrons more towards to itself. So on this case, they are sharing these electrons, but on this case, it's an equal sharing, because again, fluorine is much more powerful in attracting these electrons towards itself. So in this case, the electrons will go towards fluorine, so it will become partially negative side, or it will become partially negative because it attracts more electrons, and electrons are negative, and hydrogen will become partially positive. So here, there is a separation of charge. This side is partially negative, and this side is partially positive. So we call this molecule as a polar molecule. From the word polar, it refers to the word pole, and of course, pole, it is referring to 2 opposite sides. We have, for example, the North Pole and then the South Pole. On this case, we have 2 different poles. This side is partially negative, and this side is partially positive. So we call this as a polar molecule. There is an equal sharing of electrons. Let's go to the H2 molecule. H2 molecule is composed of H atoms. Here they are sharing these electrons, and their electronegativity is the same, 2.1 and 2.1. On this case, they have the same strength, so obviously on this case there is an equal sharing of electrons because both have the same strength. So here there is no separation of charge, so no one will become negative and no one will become partially positive. So we call this one as a non-polar molecule. It's just the opposite of polar molecule. H2, non-polar. HF is a polar molecule. Next, let's see H2O. The shape of H2O is bent, so I'll not discuss the details for this. H2, that's dalawang H. This one. So this one is the shape for H2O. So H2O, so let's discuss the electronegativity. So electronegativity for hydrogen is 2.1, the same thing for this. Oxygen, electronegativity is 3.5. Here we have 2 bonds, right? So here one bond, and this one is the other bond. Here we have hydrogen and oxygen are sharing these electrons here. But again, as you see here, oxygen is much more electronegative, much stronger compared to hydrogen. So here, the electrons will stay more towards oxygen. So we use this arrow here. So the arrow points to the partially negative side. The other side becomes partially positive. On this bond also, they are sharing this electron here. But again, oxygen is much stronger compared to this atom here. So the electrons will move closer to oxygen, giving it a charge of partially negative, and this side will become partially positive. So here, H2O molecule is composed of polar bonds. Here, polar, and this one is also polar. But overall, what's the charge of this molecule over here? Is this a polar or a non-polar molecule? If you observe the pattern here, this side, the obus, that's the side of partially positive side, and the other side is partially negative, the upper part. So here we have a separation of charge. Again, this side is partially positive, and the other side is partially negative. So here we have a separation of charge. So this one is a polar molecule. Let's go to CO2. For CO2, we have this. The shape for CO2 is this one. It's a linear shape. So CO2, let's check the electronegativity for carbon. For carbon, that is 2.5, and for oxygen, that's 3.5. Let's write that on our diagram. 2.5, 3.5, and 3.5. Here we have two bonds, this side and this side. On this side, carbon and oxygen are sharing these electrons here. Obviously, oxygen is much stronger, so the electrons will stay more towards oxygen, giving oxygen a partially negative side, and this side will become partially positive. The same thing for this side. So stronger, weaker, it becomes partially negative, it becomes partially positive. So in this case, we have two bonds and they have opposite direction. So this side is partially negative and this side is also partially negative. So overall here, because all the sides have the same charge, obviously, it will actually cancel the charge. So overall, there is no charge because it will be canceled because we have the same charge on opposite direction. So this will actually cancel the charge. So there's no separation of charge here. So overall, CO2 will be a non-polar molecule. So that's a polar molecule and a non-polar molecule.